Hello and welcome. In this video, we're going to walk through the installation process for nk2dl. nk2dl is a Python module that serves as a replacement for the default submitter that ships with ThinkBox Deadline. It's designed to be faster than the default submitter, provide some missing functionality, and provide a framework that makes it easy to integrate into existing pipelines. So let's get started. So the first thing we're going to want to do is head on over to the GitHub page for nk2dl, which is github.com/artandmath/nk2dl. What we're going to do then is scroll down to the documentation page, click on that. On the documentation page is the installation guide. We'll click through to that. The things that we're going to need is a operating system. We've tested it under Windows 10. It may work under Mac and Linux, but we haven't tested it yet. The other thing you'll need is at least Nuke 13, because it requires Python 3.7 and onwards. You'll need a Deadline 10 or later repository. And the dependencies that it needs is YAML and the Deadline API. The first thing we want to do is download the source code. There's two ways to do that, and that is, firstly, you could download it from release, follow through this link. These are published releases that are known to be working. What we're going to do is download the latest source code, and we can do that by copying this git clone command. I have a demo account for this video, and I'm in that demo user's home directory. I'll paste that in. It's downloaded it. It's down here in the home folder. I'll just change directory. And we're inside that folder. Take a look inside. And we can see the contents here. Most of what we're going to use lives in the source directory. The next thing we want to do is set up our environment and install the dependencies. If I copy this command here, python setup environment.py, paste that in, it's going to start the setup process for the virtual environment. Hit enter. It wants to know where Nuke lives. It's going to use this as its Python interpreter whilst we're in the environment. I'll just present it for the default. It wants to know where the Deadline repository is, and it needs to know that so that it can pull the Deadline API. In our case, it's the L drive. And give it a sec. It's going to pull a few things from the internet. It doesn't actually need all of this. It was, a preemptive thing that what libraries we might have needed for testing. So half the stuff it doesn't need in production, but it's downloading it to its virtual environment, so we don't really have to worry about that. Setting it up in the environment and pulling the dependencies was successful. You can see that it pulled the Deadline API from our Deadline repository and copied it into our site packages. And it's given us a command here that will put us into the virtual environment so that we can start testing nk2dl. So if I run that command, it's put us into our virtual environment. If I launch my Python interpreter, it should show us that we're in the Foundry's version of the Python interpreter. If not, for whatever reason, you can launch Nuke with a dash -t, and what that will do is launch Nuke in terminal mode. Basically a Python interpreter. It's just that it's loading the Nuke module now rather than if we had requested it, which is why it takes a lot longer to launch than the Python interpreter on its own. So I'll just exit that, go back And if I hit import, and if I type import nk2dl, it should load the Nuke2dl module. Little message here. Now it's waiting whilst it actually pulls a Nuke module. Give it a moment. This feedback here is all the debugging feedback that let us know that it's loaded the configuration, or the base configuration. So what I can do is exit. So after verifying that Nuke2dl works, what you're going to want to do is install it in a manner that the Nuke application can see it. So there's instructions here for a single user method. So as if you were dropping it into your .nuke folder, I'll take us through that and through the other way, which is to install it in a location that all users can access it, which is depending on your situation. If you're a solo artist, you might use the single user method, and if you're a facility, you'll probably use the multiple users method. So I'll start with the single user. What we're going to do is navigate to the source directory in the Nuke2dl folder that we downloaded. That was this one here, and copy the nk2dl folder that's in source and paste that into our .nuke directory. And the other two files that we'll need is in the .vmv lib site packages. You need to copy the deadline folder and the YAML folder, and also place them into .nuke. And then if I launch Nuke, open up a script editor, type in import nk2dl, hit enter. It's given us this successful configuration load here. So to install for multiple users, I'll undo what I've done and put it in, undo the .nuke install. And what I'll do is, I've got a location here on the network, which is on P drive. What I'm going to do is make a dummy pipeline. So make a new folder. I'll call this my pipeline. My pipeline. And copy the same folders, the YAML, the deadline, into my pipeline. I'll also copy the nk2dl from the source directory into my pipeline. And then I need to tell Nuke where those files are. So to do that, we just need to add the folder that contains, so I basically point Nuke in the direction of the pipeline folder that we've created, and it's a search directory that it can then find these files. What I can do is copy one of these commands from the install page here. So you can either use Nuke plugin add path, or you can add the pipeline to the system path. I'll take the second one here, copy. I'm going to make a new init file and put that in my .nuke directory, init.py. Save. Paste these commands that I copied from the installation page, and what I'm going to do is replace this path here with my pipeline path. So if I go back into my pipeline, copy and paste, and then turn this into a Linux friendly path. Save, and now launch Nuke. And now if I import the nk2dl module, it should, there, successfully loaded the configuration. The next step is an optional step. You only have to do it if you want to use graph scope variables with Nuke 15.2 or later. What I've done is written a slightly modified version of the backend plugin that comes with Nuke. That comes with Deadline. So in your source directory from the downloaded Nuke to Deadline, there's a folder called Deadline Plugins. Inside of that, a folder with Nuke. If you copy these files here and navigate to your Deadline repository, in the Deadline repository plugins, there is a folder that contains the backend Nuke plugin. I've made a little backup here. If you go into the Nuke plugin and replace these files with what we've downloaded from GitHub, and that enables the graph scope variable functionality. The final step of the installation process, if you don't have it already, is to install the Deadline web service. And I'm not going to step through on how to do that because it might vary depending on whether you're using Linux or Windows. But there are links here on how to get the Deadline service up and running and the manual for using it. It's pretty simple. You just need to have a server that you can run it on, and all your machines can talk to that server. If you do use the Deadline web service, it needs to be configured. So I'll take you through those configuration steps. The way that the Nuke to Deadline configuration works is there's a base config with defaults that you can't change. It's basically the hard-coded into the system. Then inside your Python module, there is a config.yaml file. That is the next level up that it will look to for configs. After that, it will look at environment variables, and the final step, if the user has a YAML in their .nuke directory, any setting in that will override any lower settings. So what we're going to do is set up a config file and then have a environment variable point to that config file. So to do that, I'm going to copy this example configuration. Copy, create a new file, paste it in. I'm going to save this into our dummy pipeline. Save this as my config dot my Nuke to Deadline config dot YAML. Save. Then what I'm going to do, one thing I'm going to do is tell the config where our web server is. So I think in our case it's .18. So what I can do next is set an environment variable in to tell Nuke to Deadline where to look for its configuration, and that is this YAML file on the pipeline. Hit enter, and if I launch Nuke from this shell, it'll have this config file read in. Now when I import Nuke to deadline, and take a look at its configuration debug information, we can see that our deadline, Nuke to deadline is pointing to a web service of .18. So the last step that we want to do is run some Nuke scripts to test that Nuke to deadline is working. Nuke to deadline ships with a tests folder. What I'm going to do is copy this test folder, put it onto the network. And inside of here, there's a couple of Nuke scripts. There's a dependencies Nuke script to test the dependency chain functionality, and there's a multi-shot Nuke script to test graph scope variable functionality. So I'll open this here to show what's inside. Okay, so here there's just some write nodes. The first couple have a render order of 10, the next have a render order of 20, and the ones after that render order of 40. So when we set render order dependencies on, it'll render the 10s first, then the 20s, then the 40s, and it will render them in such a way that the 20s all have the dependencies of both 10s, the 40s have the dependencies of all the 20s, so that unlike the ThinkBox model, which can only do a single dependency one after another, this enables you to sort of get renders through quicker because all the 20s are happening at once, and all the 40s are happening at once, and all the 10s are happening at once, and then it sort of gets the jobs through much quicker than the traditional ThinkBox submitter. Another feature of Nuke to deadline is the copy script functionality. The scripts that ship with the Nuke scripts that ship with Nuke to deadline for testing purposes use relative pathing and a project directory that points to the script itself. If you've ever used deadline in a multi operating system environment, or if you've used the script copy function that copies it to the workers, what deadline does is it'll break in that case because you've got a copy of the script on the worker. It no longer lives relative to all the data that it needs. What Nuke to deadline can do is make a copy of your scripts and also make a copy of scripts and resolve the project directory into a path that can be substituted by the functionality that deadline provides to make paths work across different operating systems. So you might be using Windows and Linux machines in the same environment. This enables that to work properly. So let's test that we can submit our test scripts to the farm. One thing I'm going to do before doing that is set up the configuration for the copy script functionality, which will make a backup of every Nuke script that it submits to the farm. How to use that functionality is in this page here. If I copy this one here, this YAML configuration, and add it to our config. What I'm going to do is tell the Nuke to deadline to make a copy of the script in a folder relative to the Nuke script itself. So if I do nk2dl as a token, what it's going to do is when we submit our jobs to the farm, whilst copy script is true, it will read the config and make a copy of the Nuke script into a folder relative to the script that it is submitting. And what you can do is you can make multiple copies if you want. You can put one relative to the Nuke script itself, one relative to the output, or any arbitrary location. You can use these tokens here to build a pipeline on how you keep backups of Nuke scripts that get to the farm. So what I'm going to do next is run our test that will submit our test Nuke scripts to the farm. So I'm going to set the environment again. And then run the Python script that is in the tests folder on the network volume that all the machines can see. And whilst that's happening, I'll launch Deadline Monitor. That it's going a little bit slowly, and that means that it's going via the deadline command. I know exactly what that is. We've opened up a new shell, and we haven't pointed the nk2dl to look at the config to fetch the details of the web service, which is kind of good because we can see how slow that was using it submission locally. What I'm going to do, and a couple of these will fail because we have some Macs on the farm that won't play nicely with that script. What I'll delete that. I'm going to set the environment to look for our config YAML. Set that. If I run the command again, now Nuke's loading it up again. There we go. It's doing it much quicker. And our jobs are successfully rendering, and as our first render orders complete, the dependencies free up, the second lot of render orders pick up, and when those complete, then the last set of dependencies will free up and render the final frames. So there you have it. That's how we install nk2dl into our pipeline. The next step that you would want to do is install the graphical user interface. That's in a separate module here. We'll do that in a separate video. It has two workflows. One is a panel workflow, which is what you traditionally might see in a VFX facility. The other workflow is configuring your capabilities that you need in each write using some metadata, and then basically just selecting the right nodes you need, hitting a render menu, and then it sort of instantly hits the farm, which I've found is actually ending up being much faster than the traditional method, but that is something for the next video. Thank you for your time, and see you in the next one.